Hello, everyone, and thank you for joining us today. My name is Saleem, and I'm a senior product manager here at Microsoft, focused on Azure Network Security. I'm joined today by my colleague, Gustavo Modena, who's also senior PM. So today's session will be all about helping you to get more out of Azure Firewall, and specifically when it comes to monitoring, managing, and troubleshooting your deployments. Whether like you're getting just started or you already have a few firewalls running in your production, we'll walk you through some key tools, capabilities, and also practices that can make your experience smoother and also more effective. So we'll keep it practical, demo focused. And if you have any questions, please leave them in the chat, or we should have some time at the end where we can answer them. So let's get started. So this is our agenda for today. So before diving in, let's see what we're covering today. We will start with a brief introduction about Azure Firewall. So we will have some level set on what Azure Firewall is, how it fits into Azure ecosystem, and also some of its key capabilities. From there, we'll move into monitoring. We will explore how you can gain visibility into your firewall traffic using logs, metrics, diagnostic settings, and also integrations that we have. Then we will move into management. We will cover everything from policy design to rule collection groups, rule usage reports, and change tracking. We will also show you how to manage firewalls at scale and reduce operational overhead. And finally, we will wrap up with troubleshooting. So we'll cover tools, techniques like flow trace, fast flows, latency checks, security copilot, and also firewall policy auditing. All of them aimed at helping you quickly identify and resolve issues. Along the way, we also show you a few demos and share some practical guidance on how you can apply these right away in your own environment. Okay, so let's start with the quick overview of Azure Firewall. So Azure Firewall is our first party, fully managed next generation firewall service. It comes with built-in high availability and scalability. It's designed to protect both east-west and north-south traffic flows across your Azure environment. And some of the key capabilities, also as you can see here, we have the network and application traffic filtering for both inbound and outbound traffic. So you can define rules based on ports, IPs, protocols, and it also supports filtering for specific applications, services, such as Azure PaaS services, using the application level rules. We have also the built-in threat intelligence, which can alert or block traffic to or from known malicious IPs, domains, URLs. And we have also fast deployments and auto scaling, so you can scale the service within minutes without worrying so much about the infrastructure. The Azure Firewall today supports 3 SKUs, and they are designed to match different needs and environments. So the first one we have is the basic SKU, and it's aimed at small and medium-sized businesses that need essential protection at cost-effective price, right? And it's also a good fit for larger enterprises that are looking to protect, let's say, smaller segments or dev test environments that they have. Then the next one we have is the standard SKU. This is the first SKU actually that came for Azure Firewall. And this one is ideal for enterprises that require up to 30 Gbps of scalable throughput. It supports layer 3 to layer 7 inspection, DNS proxy, custom DNS, threat intelligence, and also web categories. And finally, we have the premium SKU. So the premium SKU is built for, or usually built for, highly sensitive or regulated environments like finance or healthcare. It adds advanced features like TLS inspection, intrusion detection and prevention, and URL filtering. And the premium SKU can also scale up to 100 Gbps and support for fast flows up to 10 Gbps. So let's now briefly compare these SKUs side by side in terms of key capabilities that they have. So all these SKUs support core features like SNAT, DNAT, FQDN filtering, and they also all of them have high availability. but the differences emerge when we look at the more advanced capabilities. And these are, for example, the threat intelligence mode, which is only alert mode in basic SKU, but in standard and premium, you can have it in both alert and deny. Then we have the web content filtering, DNS proxy, and also custom DNS that are only available in standard and premium. While the TLS inspection, IDPS, and URL filtering are exclusive to premium. And in terms of performance, the basic SKU supports up to 250 Mbps, standard up to 30 Gbps, and premium up to 100. And of course, with the fat flow support only available in standard and premium SKUs. So if you need, let's say, deep packet inspection or TLS termination, premium is probably the only SKU that delivers this. Otherwise, standard also gives you a good balance between features and scale. So that's an overview of Azure Firewall. Now let's start with our first section, which is monitoring. And we can begin with the Azure Firewall diagnostic settings and specifically the structured logs here. So the diagnostic settings lets you stream platform logs and metrics to different destinations, including log analytics, Azure storage, or event hubs. And we, as always, we strongly recommend enabling this for all of your Azure Firewall deployments. It's your main path to monitoring and troubleshooting. So when you configure diagnostic settings for Azure Firewall, you will see two destination options today. You will see the first one as Azure Diagnostics, which is more of a legacy and unstructured, let's say, while the second option is the resource specific, and it's also known as structured logs, which is the one that we today recommend. So these structured logs follow a consistent machine-readable format that's easy to query and analyze. Unlike the free-form logs, these are organized by a schema, so you get rich filtering and also analytics capabilities out of the box. The Azure Firewall structured logs include detailed event information like source and destination IPs, ports, protocols, and you have also the actions taken there, along with metadata like timestamps and the firewall name. So this structure makes it a lot easier to troubleshoot and also to build dashboards and alerts using KQL and log analytics. Now, when setting up the diagnostic settings for Azure Firewall, as I said, we recommend the resource-specific table instead of the legacy Azure Diagnostics table, as you can see here, and I will show you also a bit in the demo part. So the main reason we recommend it is log separation and clarity. So with the resource-specific mode, or the logs are organized by dedicated feature tables, as you can see here. So if you enable logs for things like, let's say, IDPS or threat intelligence, each of these will have its own structure table in the log analytics. And as you can see here, the legacy, we have only 3 at the bottom, which has all the logs for the legacy table, while the other structured or resource-specific logs are divided into different features, and you can be more specific which ones you want to use in enable. So this, of course, gives you several benefits. First one is, of course, easier to query since you're not digging through like one page of combined table. The second one is you get better schema discoverability, so you can easily see what fields are available per log type. Then you have, of course, also the performance improvement, both in log ingestion and also the query time. And it also allows RBAC at the table level. So you can have more control access with more preciseness. One practical note, if you're still using or if you still need, you can use both Azure Diagnostics and resource-specific logs. You just have to create 2 diagnostic settings for each firewall, and you can have a different destination table for each of the diagnostic setting created. So it's still possible to have or to use both of them if needed. And one more thing, right? From cost perspective, using the structured logs, what we've seen is a huge lowering in ingestion costs around 70 to 80% in the log analytics, which can be pretty significant when you have a large environment. So to keep that in mind when making a decision to use the resource specific logs. And here you can see how actually they look like. So the first one we have is the diagnostic setting logs here, and you will notice that the query is it's pretty big, and that's because all the data is in the same column here. So you have to create a query or use one of the KQL queries that will need first to parse this column, all this data into more readable columns. So this is how it looks like with the legacy. With the structured logs, what you will see is that even with this simple query, and we're using here the Azure Firewall Network Rule category in this case, you can see all of the columns are separated. Data is a lot more readable and easier to query. So that's one of also the advantages you have between these two. Okay, so now let's go to the next topic of related also to logging, which is a new feature that came out recently actually, and that's the Azure Monitor Basic Logs table. So with this option today, you can configure your Azure Firewall resource specific tables to use the basic plan instead of the default analytics plan in the log analytics. And why is this important, right? So the basic logs can offer up to 80% cost savings on the log ingestion. So if you're still using the structured logs, you're still seeing a lot of ingestion costs, then you can enable basic logs and you can save even more. And this is very helpful when you're ingesting large volumes of data. However, of course, there are some trade-offs. So basic logs are intended for lightweight queries and high volume data. So they don't support advanced features like policy analytics, security copilot, or the option to have the long-term retention for these logs. So if you rely on these capabilities, you can actually enable the basic logs on some specific tables, but not on all of them, right? So you can, for example, keep the tables that you need for policy analytics or security copilot in analytics table plan, and then enable the basic plan on the other tables, which you will get the benefit of both, right? So you can still use those advanced features. And on how to do it, on switching to basic, it's quite easy. And that's you have to go to your log analytics workspace, open the table you want to change, as you can see here, select basic under the manage table, and save the configuration. And a note here, just to keep in mind, is that the table plans can only be changed once every 7 days. So this approach gives you some more flexibility and also some better cost savings when it comes to ingesting Azure Firewall logs. And I'll show you in a bit in the demo environment how this looks like and how you can enable it. So next we have is the embedded workbooks and the embedded workbook experience that's already available directly in the Azure Firewall portal. So the workbooks in Azure are in general powerful tools. They provide flexible interactive canvas for exploring and visualizing the data. You can also pull from multiple sources and combine logs, charts, filters into a single unified view. Azure Firewall today includes a pre-built embedded workbook, so you don't have to build one from scratch. It automatically surfaces aggregated traffic insights, and these include, for example, like DNS proxy activity, IDPS events, application network rule usage, and so on, right? What makes this workbook especially useful is that it supports multi-firewall multi-subscription and also multi-tenant environment, so you can have all of them in one pane of glass. You can also easily filter by, for example, resource groups, the firewall names that you have, or even the log categories. So you make it easier to drill down and see the patterns here. It's also a good point for teams to have or to start to have a quick visibility when you have when you deploy your firewalls and without needing really to build new dashboards or run KQL queries every time. Before we jump into the demo for this part, let's quickly cover the how Azure Firewall integrates with Microsoft Sentinel. Across industries, organizations are investing more and more in tools that help prevent breaches and automate threat detection. Microsoft Sentinel brings those capabilities together with built-in analytics, hunting tools, and automation, and Azure Firewall works seamlessly with Microsoft Sentinel to provide deeper insights into network-based threats. So with the Azure Firewall solution for Microsoft Sentinel, you have a prepackaged integration that includes, for example, detection rules, you have threat hunting queries, you have an interactive workbook, you have also automated response playbooks, and you can deploy the entire solution just one step, so directly from your Sentinel Content Hub, which can help you operationalize the firewall data much faster and also start generating data immediately. All right, now that we have covered the key monitoring and integration capabilities, let's switch over to Azure Portal and let's have a look at how all of this works in action, right? So I'm gonna start sharing here my portal and I will show you how it looks in the Azure Firewall directly. Okay. So as you can see, this is the portal I have open here. And the first thing that I want to cover, which I covered in the slides, is the structured logs, right? So the first thing I'm going to do, I'm going to go for the Azure Firewall resource. And it's the firewall, Azure Firewall, not the firewall policy, right? Just to keep this in mind when you're enabling the logging. So I'm going to go to firewalls, and we should have one firewall here deployed. So I'm going to open this Azure Firewall resource. And under the monitoring here, I have diagnostic settings. So I'm going to open this diagnostic settings. And you will see that we have two of them created, one for the structured logs and one for legacy. So we're sending logs for both of them to our log analytics workspace. So let me show you the configuration of the first one. This is the structured logs that we recommend today to use. So on the left side, you will see that we don't have all logs selected. We have specific categories, and you will see all of these that we have selected. These are the new structured logs. So they are based on, for example, each feature or section. And then here at the end, you'll see these are the legacy ones. And on the right side here, you will see that we're sending it to our log analytics workspace. And we have here the destination table selected as resource specific. So keep this in mind when you're doing structured logs. Make sure to select resource specific. The Azure Diagnostics will not work if you have these categories selected and this destination table. So this is the structured logs. Now, if I go back here and I go to the second one we have here, I'm going to do edit settings. And you will see that here we have the three legacy Azure Diagnostics selected, and we are sending it to this destination table, which is Azure Diagnostics. So, and this, if you want still to use them, you can enable it like this and keep getting the other logs. So if you're still using them. Now, let me show you in action how they will look like and also the difference. So I'm going to go here to my log analytic workspace, and this is where I'm sending all the logs. So the first query I have here, as you can see, I'm using Azure Diagnostics, and this is the legacy. And you can see I have to select the category, which is in this case the network rule. So I'm going to run this. I'm going to look for the last 7 days. And once the query is done, you will notice here, if I expand it, that most of the information that is here, it will be here in the message, and you still need to do like more querying to parse this information. So if you want to add it as columns and to have it more readable, so it's a bit more difficult to use it and not very well structured, let's say. Now, if I try to run this other query, and this is the new structured logs I'm running this query against, and as you can see, I'm using it against the Azure Firewall application rule in this case. So I'm going to run this, and I'm going to look for any rule or application rule where the action contains allow. And you will already notice that it looks a lot better because all the information is already parsed here. You can see the protocol, source IP, source port, and so on. So it's a lot easier to read. And another example here, this is for example, taking just 100 of IDPS signature logs just to have a look and test it. And you will see the same also, that the information is easily readable. In this case, you understand that the source IP is this. This is our source port, destination. You can see the action is alert. This is the signature ID for this IDPS, and the description of the signature that was triggered in this case. So it gives you all the information here, and it's a lot easier to use and to query. So this is the logging part. Now, for the next part, I will show you the workbook that I mentioned earlier. So let me go actually from beginning. So this is the Azure Firewall that I have selected earlier here. On the left side, down under monitoring again, there is workbook. So if you click on that, it will show you the available workbooks that are here. The one we care about is Azure Firewall Structured. Just click on it and it will open the workbook. Now, when you have this open, the first thing you have to do is select the workspace, and this is where I'm sending the logs. So I'm sending it to, in this case, to CyberSock. I'm going to select it. You will see that there is a time range. I'm looking at 90 days. There is also, like, you can select the specific firewalls and so on. And what you will see down here is a lot of useful information. For example, the number of events, which type of events happens, like, this is the DNS query, the application gateway rules, and so on. You can see the trend of these, so you have a good idea of like the trend, the data over all the firewalls that you have over the subscriptions. You can see the, for example, average throughput of Azure Firewall. And let me actually just going to select here last 30 days, so we see more in depth. And you can see here, for example, the throughput, average throughput of Azure Firewall. So you have SNAT port utilization, which is very useful to monitor network rule, hit count, and so on, right? So there's abundance of useful information, and this is just first step. Then we have also, if you want to go into detail into the application rules to understand, for example, the application rule usage, like, which rules you have that have the most, usage based by count or last log in this case. You can see denied FKDNs over time, which ones they are. So understanding also about false positives in this case, and a lot more information, right? So this is super useful, but make sure that you have the logs enabled, right? So make sure the diagnostic settings are configured and you're sending the logs to your, in this case, the workspace, and so that you can see all of this information here and start investigating or creating a report. So this is it for the workbook. And the next thing I want to show you is how to enable the new basic mode, right, for the logging tables. So here I am in the log analytic workspace, and I have selected the log analytic workspace where I'm sending all the logs, right, in this case. So what I'm going to do here, I'm going to go under settings, tables, and under tables, you'll see all the tables that you have. So I have to search for, in this case, for Azure Firewall. Let me search it like this. And okay, you can see all the tables here. You can select, for example, table here, do manage table. And then here under table plan, now you can change it to basic. And this is where you have a lot more cost reduction. But there are, of course, also, like, as you can see, no interactive retention or lower retention period. And this is how you change it to basic. As you can see here, you can select specific ones. So you can, for example, enable basic only the ones that are not for policy analytics or security copilot. So this is basically it. It's pretty straightforward on how to enable it. So if you were having trouble maybe with high cost of ingestion, you can try this new option. So for the last part that I want to show you are basically the Microsoft Sentinel integration. So here I'm in the Microsoft Sentinel. I went to Content Hub and I search for Azure Firewall to see all the Azure Firewall content that we have today. So this is the solution for the Azure Firewall. And as you can see, we have a few analytic rules. We have, for example, down here, the hunting queries. We have also playbooks and workbooks, and of course the data connector, right? So all of these can be deployed with just one click, and you can start using them. You can start using the advanced hunting queries to find, for example, here on the common port for organizations that you have, or you can also do analytic rule for if you're looking for like several deny actions registered to have a good or an idea about like a pattern that's happening in your network layer. So these are super useful to understand, to do advanced hunting queries, to also use the workbooks and also the automations or the playbooks here to automate, for example, adding IPs to a list or to another new rule. So these are the available Azure Firewall integration with Microsoft Sentinel is available today. Okay, so I'm gonna stop here. I'm gonna now give it to Gustavo, who's gonna finish the rest of the sections. Gustavo, I hope it didn't take too much of your time. And go ahead, you can take over.
Hey, Saleem, thank you. No, it was perfect on time. Hello, everyone. My name is Gustavo. I hope you can see my screen. Can you confirm that, please?
Yes.
Thank you. All right. So yeah, right now I'll cover the management and the troubleshooting portion of the webinar. And to start with the management, I would like to mention some of the tools and the ways that we have available today to manage, not only manage, but deploy and manage Azure Firewall, right? So we have the most common, which is using the Azure portal, using the user interface, so you can deploy using the marketplace to find a firewall and then deploy it from there, just using the deployment flow, and then manage the firewall completely through the portal. Or you can use infrastructure as a code. And then when we talk about infrastructure as a code, we have support to Terraform, ARM template, Bicep. Actually, I just noticed that I missed a P in Bicep here in this slide, but yeah. But yeah, we have a Terraform, ARM template, Bicep, and we can also interact with the REST APIs. A lot of people ask us about, hey, what's the best option to manage my firewall? What are the most effective ways? It really depends on the experience and the amount of deployments that you have, right? Because a lot of, some customers, they only have like 1 or 2 deployments. They don't have a lot of people managing those firewalls. And then for them, it might be easier just to go through the portal and make the changes. Maybe they don't have a lot of changes to make on the firewall, and that's just easier to use the portal experience. But then for other customers that, they may have more line of business, different firewall deployments, many specific rules and rule collection groups. For those, using infrastructure as a code would be the ideal, right? It helps scaling the process of managing and making changes on firewalls. If you have a specific control or process to approve changes in a maintenance, window, so you can just submit some, changes on the JSON files if you're using ARM templates or in the Bicep files, and then once it's approved, it's going to be applied in production. So using the process of infrastructure as a code. So it really depends, right? I would say that of course, there is a learning process when using infrastructure as a code, because you need to, number one, define what's going to be the language you're going to use. And then number two, you need to be familiar and get familiar with the process of deploying and using the best practice when using these templates, right? One thing to mention here is that in Azure Portal, if you are not familiar with either of those options, now you can deploy using the portal and then export the template to ARM template, Bicep, or even convert to Terraform. So that's really good way to get to know more about these languages, and then start practicing and getting familiar and learning more on how to use in production environment. Okay, so and then one thing that I mentioned here, even though we are saying deployments here, you can use these not only for deployments, you can use for deployment and management. So whenever you have a change to make on your firewall policy or on your firewall configuration, you can just go to your templates and make these changes, right? I'm gonna show a little bit more when we go through the demo. The next thing that I want to talk about is the management NIC. Management NIC was previously called force tunneling, right? So it was originally a management NIC that was required for force tunneling when you had, let's say, for example, on a hybrid environment, and then you wanted to have the internet connection from being sent back to on-premises, right? So you would apply some static routes to your firewall subnet, and then send this traffic back to the on-premises. So all the internet traffic would go through whatever internet link you would have there, right? But the point is that for some specific features in future, Azure Firewall might require the use of the management NIC. So we renamed, instead of calling these force tunneling, we are calling it specifically management NIC, not only for future feature releases, but also if you think about the basic SKU, right? The basic SKU, it is by default deployed using the management NIC. It doesn't give you the option to deploy without the management NIC. And for the firewall standard and the premium one, if you were deploying through the portal this day, it is by default selected the option of deploying using the management NIC, right? Of course, if you don't want to deploy using the management NIC, you can just go in and disable that, but that's the default option that's being selected when you deploy a new firewall through the portal. One thing to mention here is that when you deploy the management NIC and you start using it, there is a requirement of having an additional subnet. So if you're not familiar, when you deploy Azure Firewall, or previously when you used to deploy Azure Firewall without the management NIC, you only had to have one subnet, right? Which is called Azure Firewall subnet. But then if you want to enable the previously called force tunneling or the management NIC, then you have to have a new subnet, which is called Azure Firewall Management Subnet, which also requires a /26 address space, right? So that's one thing to take in consideration when you are creating a firewall with the management NIC. And I think that the most important thing about this feature here is that it has a traffic separation, right? So Microsoft needs to control the updates of the Azure Firewall, right? So it doesn't, when you have the management NIC enabled, it doesn't use the only one interface for traffic and management, right? So it's going to use a dedicated NIC for the management for all the updates that are being managed by Microsoft. So it doesn't conflict with your traffic coming in from into your workloads. So that's the biggest advantage of using the management NIC. Okay, so talking about management, it is important to mention about firewall policy. For those who started using Azure Firewall in the past, like in 2018, it used to have only one option, right? When you created a firewall, you would start creating the rules right on the firewall. which now we call as classic rules. So you would be using the classic rules. And then a few years later, we released the firewall policy, which is a top-level resource that can be shared across different firewalls, different subscriptions, and it allows you having a separate resource just for managing all the rules and all the configurations on your firewall, right? When you deploy a firewall policy, you have three versions or three SKUs for the firewall policy, which is also basic, standard, and premium. And there are some, let's say, for example, you created a firewall policy standard and you want to use TLS inspection or web category, not web category, sorry, TLS inspection or ADPS, then it won't be available because the firewall policy is a standard one. So you would need to update that to premium, and then you will be able to use those premium features as well. If you are using the classic rules these days, there is an option through the portal to migrate. So the migration process will basically copy whatever configuration you have in the classic rules and then create a new policy with all those configurations and then associate the policy with your firewall. And you can also do that using infrastructure as a code. And then when you do that using infrastructure as a code, is a little bit easier because you only need to change a little bit. I would say you need to create a new resource, which will be the firewall policy, and then make an association with the firewall. So the process is simple to be made. It doesn't require any downtime because the association of the policy with the firewall can be done online. But again, right, we always recommend, even though it's not expected to have any downtime, we also recommend that doing that in a maintenance, a planned maintenance window. So if something not expected happen, yeah, you still have time for troubleshooting and call the support to help you figure out what went wrong and have your policy migrated to your rules migrated to firewall policy. One thing to mention is that the firewall policy is high available resource. As I said, it's a global resource that can be used across different firewalls and subscriptions. So if a region where your policy is deployed has some failure, you won't be impacted. Okay. Next, we have the policy hierarchy. So using firewall policy, you have the option to create a structure or a hierarchy structure using parent policy and child policy. Let's say, for example, your organization has one team that defines global security rules that can only be changed by them, nobody else, and then other teams managing firewalls at the specific line of business level, and they need specific requirements, right? So in this case, what you can do is use this hierarchy to apply the global configurations in the parent policy. And then once you have the parent policy, you can attach to it a child policy with your specific configurations. When you are using the policy hierarchy, there is a order of processing. So everything coming from the parent policy will be processed first, and then the child, all the configurations in the child policy will be processed next. So when using these configurations here, you allow a segregation of the firewall management, and you can define what are the teams that can make changes on specific policies and specific changes to the firewall as well. Okay, now talking about the rule collection group and rule collection, I think this is one of the questions that we get a lot here at Microsoft from customers asking us, how should I organize my rule collection groups and my rule collections? And there are, we do have a blog post in the tech community. I can show you I will show you in the demo this blog. But what we recommend and what we are seeing working for a lot of customers is using a rule collection group per workload, right? So let's say, for example, you have the HR systems, and then you need to specify specific rules for the HR systems. So you would create a rule collection group, and within this rule collection group, you would create the rule collections for the systems from the HR with the specific rules allowing source and destination. And then you can just keep using the same idea for other workloads as well, right? If there are common workloads or shareable workloads that use the same configurations or the same security policies, you can have a rule collection group shareable, between them. But the idea is really to use these rule collection groups and rule collections to organize. One thing to mention is that a rule collection group is the first unit to be processed by the Azure Firewall, and then it follows a priority order based on the value. So when you create these rule collection groups, you need to define a priority for each one of them. And then within the rule collection groups, you will create rule collections. And the rule collections, we have three types of rule collections, being one for net, one for network, and one for application. And within each one of these rule collections, you can only have rules of those types. So if I have a rule collection network type, I can only have network rules within the rule collection. And the same applies for rule collection groups of the application type and the net type, right? So yeah, we're gonna share the link here about the rule collection. That's just one of the recommendations, right? There are customers that are not using really the model of creating a rule collection group per workload, but that's what we've seen being a good approach for many of the customers who have many different workloads going through the same firewall, and that's the best way for them to organize and do the rules and see specify the specific the specific priorities for each one of them based on the rule collections. Yeah, one thing that I saw one question in the chat that about the rule processing, right? One other thing to mention is that not only the rule collections has a priority, and which means how the Azure Firewall or these rules will be processed, but the Azure Firewall by default has a rule processing order, right? So by default, net rules are processed first, and then network rules are processed second, and then application rules are processed at last, right? So when you are organizing your rule collections and your rules and your Azure Firewall policies, it is important to have an idea of what are the specific rules you're going to be using. I mean, between network and application rules and the priority you're going to give to each one of them. Because sometimes we see customers saying, hey, I have these application rules here, but the rules are not getting any hits. Everything is going through network rules. And that's because sometimes they are using network rules too broad, allowing traffic from any to any. And then when the Azure Firewall is looking for the rule matches, it finds any to any rule, and then that's the first one to be processed, and that's why the application rule will never get a hit, right? So it's really important to have this, take this into consideration when you are designing your rules and your policy, to not be too broad on the network side, and then having your application rules not getting any hits because of that. All right, then talking about the IP groups. IP groups is another resource that can be used in your firewall policies. The idea of the IP groups is really to simplify the grouping of IP addresses and IP ranges. So when you are creating your policies, instead of creating, specifying the source and the destination IP addresses in each one of the rules, what you can do, you can create IP groups, and let's say, for example, IP groups for specific networks or to specific applications. and then use these IP groups across different rules in your firewall policy, right? So that's the easy way to manage the configurations you have and the security policies you have. Let's say, for example, you need to make a change in or maybe add an IP range in one IP group, right? If you're using the IP group, then you just need to add the IP range to the IP group, and all the firewall rules using the IP group will be automatically updated. And then, you don't need to do anything else. If you are not using the IP groups, what you're going to need to do, you're going to need to go to each one of the rules that are associated or related to specific traffic, and then make the changes adding the IP ranges that you want to add, right? One thing here to mention is that we can add specific IP addresses like /32 IP addresses. We can add a range of IP. So in the screenshot here, we can see that I'm allowing the 10.0.102.10 to 10.0.102.15. And then we can also specify by using the feed-r the notation, right? So 10.0.101.0/23. So that's another way to do that. Okay, so and then the last one on the management part is really the policy analytics. The policy analytics is a solution that is a tool actually that's available with the firewall policy, and that allows you to have some insights of your policy, showing you some limits of the policy. You can either find rule hits like network and application rule hits. You can see some events of the IDPS in threat intelligence, and you can also run a single rule analysis to find if there are rules that have low utilization or no hits at all, and then you have the option to change those rules to a low priority rule collection group, or even to delete the rule and keep your firewall policy a little bit simpler, right? You keep the hygiene of your firewall policy. But yeah, that's a pretty good tool for analytics. It helps you maintain your environment and see if you are if there are any improvements that you can make. Like for example, not use wildcards in your network rules, or even if you are using multiple IP addresses, it recommends you using IP groups and so on. All right, going to the troubleshooting part. We have the flow trace logs. So the flow trace logs is a feature that has that is part of the structure logs that Saleem just talked about, and it helps with tracking packets in cases like, for example, asymmetric routing, right? So let's say you have someone complaining about not being able to establish a connection. So Azure Firewall will not show you the rule hits about that. And here you can use these flow trace logs to see if there is any kind of invalid packet, right? If you see an invalid packet, it means that Azure Firewall never saw that flow, and it marked the packet as invalid and dropped the packet. So that would be one of the scenarios that we have for asymmetric routing, and that would help you troubleshooting asymmetric scenarios where someone is complaining about connection is not being established between source and destination, right? That's a feature, again, that's available through resource-specific log. You can use it just by running some custom queries, and that's really helpful for the connection issues. Then we have the fat flow logs. The fat flow logs, this one is not enabled by default. When you have your Azure Firewall, you only recommend using this log for specific troubleshooting scenarios. So if you are concerned about the exceeding limits of the Azure Firewall throughput or something like that, maybe you have some questions about specific connections consuming a lot of the bandwidth of your firewall, then we recommend you using these fat flow logs. So they will give you the information of what are the top connections consuming the Azure Firewall bandwidth. And in order to do that, it it has to process all the packets going through, all the traffic going through, and make some calculations. And that's why we don't recommend having this log enabled all the time, only for troubleshooting purposes, because it can consume a lot of CPU of your Azure firewall, and then compromising the performance of your firewall as a whole, right? So one thing to take consideration is really only to use this one when you're troubleshooting. Our documentation shows how to enable these, not only in the structure logs, but you also need to make a configuration in the firewall itself, running a PowerShell command, so you can enable these the fat flow support. This is the command, so you need to just run the command to enable the log at the firewall level, and then this is the line the firewall enable fat flow logging has to be equals true, right? When you do that, your firewall will start processing all the flows, and just keep in mind that by doing this, it will consume more CPU, and depending on how much your firewall is being utilized, it will just add to that. Maybe it will affect users if you just leave it enabled by default. The latency probe metrics, this one is a good one to take in consideration when you are having latency slowness in your environment. We always recommend you all taking a look at these latency probe metrics. It's going to show you the latency between the firewall instances. So there is a process of probing all the firewall instances, and that probe will show the latency between each one of the instances. It doesn't really show the latency added end to end, so from your source to the destination going through the Azure firewall, but it gives you the idea of how healthy is your Azure firewall. If you see the latency going like a huge spike for, let's say, 5 minutes, 10 minutes, or even more, and then that is matching with user complaining about slowness in your environment, then that may indicate something wrong with your Azure firewall. And in that case, you would need to open a support ticket and work with the support to figure out why your firewall is showing, these high latency metrics for you, right? So this is a good way to check your how healthy is your environment as well. The resource health is one resource that actually is an integration that will show you some of the alerts for your firewall. So here you can find, statuses indicating the availability of the firewall, if it's available or not. If there is an unknown issue, you're going to see an indication of that. And if it's degraded, it's going to show up here as well. We are still working on adding more and more signals here. So if something goes wrong with the instances running on the Azure firewall, then it's gonna show up here for you. And if you see that, and again, it matches with some users complaining about slowness or issues, you can use that information to open support ticket, and then work with the team to figure out what's going wrong with your firewall and have that fixed as soon as possible. The Security Copilot, this one has just been released in GA, and the reason why it's in the troubleshooting part is because it really helps with the investigation of security threats. So it only works with IDPS logs, and it helps you make an investigation on what kind of malicious activity is going through your Azure firewall. By using this one, you can not only find what are the signature hits in your firewall, but you can also find, more information about specific signature IDs if you don't have enough information about those, and then just use that information for your threat hunting and trying to understand more about what's going on through your firewalls. The advantage of using the Security Copilot is that this one is available directly through the portal now, so you can just click on the Copilot and starting asking your questions in natural language without having to know a lot about custom queries and building your queries from the scratch. And then it also allows you to do the investigation across all different firewalls that you have. So let's say, for example, in this example, we have a rule hit showing an alert, 27,000 rule hits on, which is an alert, right? If you want to see if that one is also, if that signature ID is also being seen by other firewalls, that would indicate some kind of, the specific traffic being explored in your network, then you could just use the security copilot and ask if any other firewalls are seeing the same hits in the logs. And then last one, I think that's the last one. Yeah, that's the last one, is the auditing firewall policy. This one is in preview. Azure Firewall doesn't show you what are the changes being made in rule collections in your firewall policies through the activity logs. So you can use the Azure Resource Graph now to run some queries and find what are the changes being made in your firewall policies, figuring out what's the old value and what's the new values. And then you can use that feature now for tracking changes that have been made to your firewall, and help you on troubleshooting if something, let's say for example, someone changed the configurations of your policy and then something stopped working out of nowhere. I know we are at, getting close to the end. We only have 1 minute, but let me go through the demo of the change tracking. So for the change tracking, as I said, you're gonna need to go to the Azure Resource Graph. Why this one is not showing up here? Okay, maybe here. Azure Resource Graph. Go. Graph Explorer, Resource Graph. Actually, I need to go to the Graph Explorer. Resource Graph Explorer. And then here we're gonna need to run a query to find the changes being made in our policies, right? Here I have one query already saved. That's one thing that you can do if you have these being shared across, your security and network teams. You can just save a query and then run the query directly to the portal without having to, copy and paste it. And then here, I would just run the query. It's going to parse all the data in specific columns to me in a way that I can easily find what are the changes being made to my firewall policy. So here you can find the name of the policy, right? And then the name of the rule collection and what kind of change was that. So it's gonna show you it was an update. And then if you click here on see details, then you're gonna find what are the changes being made. So in the change key, it shows you exactly what are the rule that has received the change and the specific field on the rule that has changed. And then you can see down here, what are the changes. So the previous value was nothing, and then the new value now is, oh, come on, is Azure Cognitive Search. So it means I added this new tag to my policy. And then one other change here was at the TCP ports. So I added the 8081 and the port 8080. They were not part of my rule. And another change that I've made here, I changed the protocols, right? So previously I was accepting any protocol in my rule, and now I'm just accepting TCP protocol. So that feature is currently in preview, but yeah, we've received a lot of good feedback from customers on this one, and I highly recommend you all to use these to help you tracking changes made in your firewall policy. One other thing to mention here real quickly is the policy analytics. So if we go to our policy, and then down below here we have the policy analytics. Again, you need to have the structure logs enabled, and then once you have the structure logs enabled, you can enable the policy analytics as well. And then here you can find a lot of good information about your policy in general. Like, for example, I can find events here about threat intelligence and IDPS. So if I want to make some decision on creating block rules for, from requests coming from these IP addresses, I can just create them. So I will stop having these IDPS events being triggered in my environment. Then we can also find what are the recommendations for rules with low utilization. So it's going to show me based on heats, what are the rules with low utilization. And then I have these recommendations to delete or move these rules to a lower priority rule collection. And one other thing to mention here that I think it's really important is the use of the rule heats up here. So traffic flows, you can see the traffic flows that kind of show you, active flows or flows going through your firewall. And then in the application network and DNet rules, you can see all the heats of those based on those flows as well, right? So it helps you on troubleshooting, managing your firewall, making sure your policy is cleaned up. All right. So that's it for the demo. I know you're maybe 3 minutes past the hour. Do we have any questions that we need to verbalize?
Thanks, Gustavo. It looks like we have all of our questions answered in the chat. So we do have all of those answered. So I just wanted to say thank you so much to Gustavo and Saleem for being our guests today and for sharing that great information with our community. Also, thank you to the Q&A team who helped us with answering all of those questions and providing the resourceful information. To all the listeners still on the line, if you're someone who wishes to aid in the protection of the world from cyber threats and desire to have a say in shaping our strategies, blueprints, and recommendations, then we invite you to become part of our security community. Together, we can make a global impact. So join us at aka.ms/securitycommunity. This is also where you'll be notified about the upcoming webinars, events, and other announcements. For those of you who may have additional questions on the topic we just covered, or other product-related questions, please feel free to raise them on our Microsoft Tech Community Discussion Space at aka.ms/ANS-community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.